Okay, in this video, we'll be going over the generic channel object. So recall, this is just the empty channel. It basically serves as the superclass or the parent object for all other channels. So this channel doesn't really have any meaning on its own, but it is useful to understand how it acts as a parent and a foundation for the other channels. So all other channels inherit the different properties and methods of the generic channel. So the setup that you'll see in this video will correspond to other channel objects. Okay, so to create a channel, we'll call it a channel C. We can just type channel.create, and to create a generic channel, we just leave the create function empty. So as you can see, C is now a channel object, and some of this stuff doesn't have much meaning yet, but basically you can see, there's an empty channel matrix. It by default creates just a one-by-one channel, so it, the array at the transmitter and the array at the receiver of the channel are just, single elements. It by default just sets some of these other values. So the first thing we may want to do is to set the carrier frequency. So to do that, we can just do this. We'll define the carrier frequency, say as, let's say, 2.4 gigahertz, and then we can just set it using this one line. And if we do that, we can see that the carrier frequency has automatically been set. In fact, the carrier wavelength has also been set. This is not correct in a practical sense, because it's basing this carrier wavelength off of a propagation velocity of 1. So no worries, we can set the propagation velocity as the standard 3e to the 8, and we can set it using that function. If we look at C now, we can see that the propagation velocity has been set, the carrier frequency has been set, and the appropriate wavelength has been calculated based on the two. Alright, so now we can set the transmit and receive arrays. So let's go ahead and create a transmit array ATX. We'll go ahead and call it, create it as, let's say, an 8-element uniform linear array. It doesn't really matter for this example the actual geometry of the array, but for the sake of it, we'll just create an 8-element uniform linear array along the x-axis. For the receive array, we'll also create a uniform linear array, but let's say with 4 elements, just for the fun of it. Okay, to set these arrays, you can do so in a few different ways. So we can set them one by one, so using set array transmit and ATX, and then similarly set array receive ARX, and this will set the arrays. And notice now if we look at C.array transmit, the transmit array, we can see it's the 8-element array, and if we look at the receive, it's the 4-element array. And if we look back at C, we can see that the number of transmit and receive antennas have automatically been updated based on the arrays that were set. Also, we'll get to this shortly, the normalized channel energy has also been updated. So this is by default set to the product of the number of antennas. So it's often the case we want to normalize the channel energy, so the Frobenius norm of the channel matrix, to be the Frobenius norm squared, that is, to be the product of the number of antennas. So this is automatically updated based on that. You can also set the arrays using a single function. So the first argument is the transmit array, second argument is the receive array, and we can see that this has achieved the same thing. So either one works. So now to back to the last part of the generic channel is to look at this channel normalization, channel energy normalization. So if we want to force the channel matrix to always be normalized to the same amount, sometimes this is the case, sometimes you want to do that on average, sometimes you want it to be every time. If we want it to be every time, we could force it so that it scales the channel matrix, no matter what it is, to have the same channel energy every time. So to do that, we can just type set force channel energy normalization, and we can set this to true or false. So by default, it's set to false. If we want it set to true, we can just set it equal to true like that. And if we want to change the energy that the channel is normalized to, we can also set that using this. So if we want to set it always equal to 1, for example, we could do that. And if we look back now, we can see that the force channel energy normalization is set to true, and the normalized channel energy, the energy that it will normalize all channel matrices to, is equal to 1. Okay, so this concludes the generic channel tutorial. This is obviously not very useful, and that's by design. Recall, this is just the foundation for other channel objects. So the relay channel, for example, will inherit all of these different parameters and methods, but this is just an introduction to the core foundation of all channel objects. And stay tuned in the other videos on other channel objects for more information about specific channels and how to realize these different channels.